concept of damping ratio, as well as the what are the changes will happen and the mass is changed, as we can see this. And if I increase the damping, so there is no decrement in only. And what if we change the length and damping frequency as well? So these all things will change. We can see from this side. So this is the explore phase. So this is just made for a user to understand the concept and know about the variables and how the variables are related to each other. So this was the explore phase. So once the user complete this, so they can go into experiment. So let me take one or two experiment. So let's say experiment 2. So once I select this, so again this also requires the Adobe Player to be Flash Player to be enabled. So which I have already enabled. So that's why. Otherwise, it will give you information to switch on that. So in the experiment also is the same page only, but here in the controls we have something different, and the variables and these are constant, and if constant, and otherwise if you go and execute an experiment, they will be constant there only. So once I start the experiment, so this is the experiment. So once I start the experiment, so the page will take us to this page, and there I have a displacement versus time graph and the fast Fourier transformation here. And here, this is the experiment here. So the experiment asks us to find the logarithmic decrement from the displacement versus time graph. So if a user wants to do that, they can calculate it and they can keep it here. So I'll quickly calculate it. I have a calculator here. So anyone wants to give answer for that? I need to check it for here. So displacement one is displacement. This is 100. So it gives you a real-time feedback if your answer is correct or not. So let's say if I put some wrong value, like that answer is wrong, so please calculate again. And the very best thing here is if you hover your cursor over the question mark, user will be given with the equations and variables and some kind of hints, so they can uh, go through it and they can start their experiment again. So once we are done with this experiment, a user can reset the experiment and they can change. So in this time, we have different setup. So the displacement is different. So and if I reset again, oh my god, like all the values and everything is changed. Material, cross section, length. So this gives a very good option. So they don't have to do only one experiment. So if they reset, so the reset page will take them to different experiments. So this was the one of the experiment for finding the logarithmic decrement. And there's one more experiment here in experiment 3. If I select here and I'll go for start experiment, so this is asking for natural frequency. So natural frequency is in is omega d by 1 minus uh, damping coefficient, and all the values and the variables has been given here. We just need to put the values in calculator and we can find that. So I'll leave that for you, and if anyone wants to give the answer for that, please feel free to answer in the chat box, or one can enable their mic and say the answer. Lab only. So I'll go back to the experiment. So I'll start 2 degree of freedom vibration. So once we enter into the experimental page, so we have the theory here. So as you can see, very detailed and theory has been given and all the formulations and equations required to execute the experiments has been given. So same setup of the page, procedure, self-evaluation, simulation, assignment, quiz, videos, references, and feedback. So I'll directly go to the simulation. So I have two options here. That is uh, explore phase. So this is explore phase, and again the same here, experimental phase. So as we can see here, there's a 2 degree of freedom. Spring mass system is there. So we have one mass 1 and we have mass 2 and 2 spring constant. Force omega K1, M1, K2 and M2 can be changed. So let us change omega K1 and decrease into 20 constant. So we can change these values and we can see the change in the both over here. So if I pause this and I can go to the next page, and here I have the magnification factor for both mass 1 and mass 2. And this is also real-time searching for variables here, and we can see the corresponding changes over here and as well as here. So I can again go back and run the simulation. So this is the 2 degree of freedom system, and in the experimental phase, okay. So uh, we'll go for the next simulation. There's rotating imbalance. We'll go for the simulator. So we have the setup here, and there's a displacement versus time graph. And as you can see, there's a rotating imbalance mass rotating over here, spring mass, spring damping system. So in the variables, the stiffness is given, mass and damping ratio. Balance mass and the rotation speed can be changed. So let's increase the, so let's keep it this mass I will increase. Damping ratio, let's increase. And the thing is, once I change the variables here, you can see the mass and the rotating unbalance as well can be seen here. And the rotation speed, let's increase. So if we increase too much, it will show like this. So let's keep it in this way. Increase, decrease the damping and increase stiffness. So this gives the user to understand variables and their with them. So how the stiffness is uh, affecting here, how damping ratio is here, and how the mass is behaving here. It's, and in the same way as in the first experiment, we can go to the graph, and the graph here given as so. The thing here is, if I play this button, I have again the option to change the variables. So let's increase the stiffness and increase the damping ratio as well. So if I go back to the graph, so now I'll have a second curve that will be of different color. So this is the result of the second experiment. So in this way, a user can do multiple number of experiments while changing the things. Sorry, and again. So if we do that, then the graph will change. So once the user is satisfied with their experimentations and all the things, so you can clear the graph and you can start again. And if you want to see the recent graph, so you just clear it. So this was uh, all about the vibration lab. So before starting presenting other labs, so I would like you to uh, go through the experiments, and if there is any query about these things, so you can ask me, and you can one of you can present the experimentations as well. I'll stop my screen share, and once we are done with this lab, we can proceed further for the next lab.
Sir, I have doubt in this. If the damping ratio is less than 1, then the displacement versus time curve, it has to come sinusoidal, that is in the form of exponential curve, sir.
Hmm.
When the theta is less than 1, when the whether it is the subjected to free vibration or forced vibration, the displacement versus the time curve or response curve, it is going decaying, sir. It is a decreasing order, but it shows in the simple harmonic motion.
Sir, actually, if I answer for that, no, this is a forced vibration test. So the excitation will be continuous.
Yes, sir.
And time domain, no, amplitude will be continuous. So if it is a free vibration test, then there will be a decay in the amplitude versus time curve.
Even
Exactly,
though
sir.
if you provide the damper also, sir.
Yes. Even though it may be any damping value, if it is subjected to a forced vibrations,
Yes, sir.
so it may give the less amp is a high damping. If you decrease the damping in the time domain curve.
Okay. Thank you, sir. Thank you.
So, sir, I would like anyone who's interested, they can present, and I'll stop my screen sharing, so they can share their screen and perform one of the experiment. Other than this, or with this one only. So,
So I'm
I'll
interested
stop it.
in presenting. Can you please help me into?
Please, sir. So I'll mute my mic so you can speak as well at the same time. So,
Uh,
and once you
so
need,
I'm VLab. What is it?
yes, sir. vlab.co.in.
Yeah, VLab dot. Yes, in that one. So new lab. Which tab do I need to select?
Sir, please share the screen.
So it will be better if you share your screen, so I
Yeah,
can
sure,
guide you
sir.
better.
Just wait for a second. Sir, my
Yes, sir. I
screen.
can see your screen. So,
Uh,
you need to scroll down, and
yeah,
in the broad areas, you can find your lab here.
mechanical engineering. Yeah. So here, I want to take this again, sir. Dynamics lab,
Sure. There's a vibration.
machine,
Uh,
dynamics of machines lab.
no. This is different lab, sir.
Yeah.
If you go
Vibration
down,
and acoustics lab. We want
machine,
to.
yes, machine dynamics and vibration lab. Above
Okay.
that, sir. Above that.
Yeah. Right. Machine dynamics and machine mechanical vibration lab. So these are the experiments. Software vibration, vibration, fixed beam. No? So shall I take this one or base excitation?
Actually, I cannot see the thing on the screen.
Is that so? I have been to now experiments.
I cannot see that.
So here several experiments are there. Free vibration cantilever, simply supported beam,
I think, sir, you
vibration.
need to share your entire screen. I think you have shared
Yeah, in
only
fact, I
one
did
tab of
that.
your Chrome.
One second. I did that in 1 minute just.
No, he has shared entire screen. Maybe
Okay.
I think, sir, you have shared only one tab, so it will be better if you screen share again.
Where is the option for the
Yes, now I can see.
for screen?
I can see it now.
No, sharing entire screen. Where is the option?
Once you go to share screen, there's the option to share entire screen. Now I can see your
Yeah,
screen.
yeah, that is fine, sir. But I am thinking to share the entire. Okay, fine. Anyways, now it is.
now you can click
Okay.
on the experiment.
Yeah, I did that, sir. Actually, now I will take a particular vibration of fixed beam. Okay, sir. Is that fine?
Fine, sir, you can go.
Yeah. So now procedure self-evaluation. Okay. Shall I go to simulator, sir? There I can perform some.
Yeah. Simulator.
Yeah, simulator. Okay. I think flash player. I think. Yeah, this is the fixed beam. Start experiment. Sir, this is the it represents the tab represents a procedure, no, sir? Actually.
Yes, sir, this is the procedure, and it's a very good practice if you start from there, but right now you can only
Yeah.
demonstrate it.
Yeah, demonstration for the demonstration, I should go for simulator.
Simulator.
Yeah. Okay. But here, sir, Adobe Flash player is blocked. It shows something like that. What I need to do for this?
I think your
So you need
system.
to go to your site setting. From the site setting, you can enable Flash Player if it is installed.
Can you repeat that, sir, please?
Folder.
So in the site setting, if you go to in settings, there you can
Set,
enable.
setting. Settings.
Sir, in the browser settings, you will have it.
Oh yeah, I'm actually, in fact, I'm doing that, sir. Settings. Where I need to go, sir, for settings?
If you actually, we are not able to see your settings and all those pages, so it should
Sir,
be a
in,
little bit difficult for you.
sir, in settings,
Yeah.
you will find this.
Scroll down, there will be
Yeah.
option there.
Yeah, actually, in fact, I'm doing that, sir.
Site setting. In site setting, you will find Flash.
Settings, flash. Site settings, yes, sir.
Yeah, site setting, you will find there is a Flash.
Flash, okay.
Yeah, you just click
Drive.
it, and above the task first will be there. You just click it.
Flash it is there, yes, sir.
Yeah. You just click it, sir. Ask first.
Block sites from running flash, it is there. Shall I do that or
No. Just you click it. That ask first. That should be on condition. That's all.
ask first? Yeah.
Yeah. That should be in click.
Yeah, I did that, sir. Now it is in blue.
Okay, sir. Now you'll get it. Yeah.
So
Yeah.
once it's enabled, you just need to reload your web page.
Again, I need to reload this one.
You just need to reload and
So I will rejoin that again, sir, then.
sir.
Shall I rejoin the meeting or shall I need to continue?
You can continue, sir.
Yeah, okay, sir. Actually, I'm going to simulator. It is showing more or less. I think same things are flash allow. Okay, 1 minute. Yes, sir. Now I think.
Yeah, you can go back again.
Experiment. Yeah, yes, sir. It is there. So this is for the fixed beam, which is having cross
And
section.
yes, sir. Before that, there's the explore phase also. If you want to go through that, but okay, you can demonstrate this also.
Pardon me, sir, please.
There's the explore phase also, sir. As I explained in the first experiment, there are two. If you can see on the top, there's the explore phase and there's the experiment. So you are in experiment 1.
Yes, sir. Yes, sir.
So in the explore phase, you can select that and you can change those variables.
Yes, sir. Yes, sir. Yeah, yeah. These are the variables. Yeah. Material steel, cross section is length, die kg. These are the settings. First, I need to do first, no, sir?
Whatever, sir. It's up to you. You can choose anything and
Yeah.
you can.
Yeah, yeah, yeah. Okay, sir. Then experiment 1. So this is fixed free vibration test. Start experiment.
Screen is not shared.
Oh, is that so? 1 minute, second, sir.
No, it is visible, sir.
Screen is visible, sir.
Screen is visible.
Okay,
Need to
okay,
do
fine, sir. Fine.
switch on the.
So find the stiffness from E, I, and L. Okay, this is the one. For fixed beam, we have some equation for, and there is a relation between stiffness and E. So there will be equation for K and E. Yeah, what the stiffness?
For simply supported, sir, it's I think 48 EI
No,
upon.
this is fixed beam, sir. This is fixed beam. It is not actually the
Okay, yeah, yeah.
simply
Fixed
supported beam.
Yes, yes.
So there will be equation. So relation between the stiffness and the EIL. Since we have already freezed the I section and what is that moment of inertia I and length of the that is beam. So then stiffness of the spring that we need to give, I think.
Yes.
So then you will get the value of E. So otherwise, if you know the E, then we can calculate K.
Actually, sir, the material and everything is given. So if you select that, you can get the value of ES. So
Yeah, yeah,
material is
that is
steel.
material is K, that is steel, we can get the E value. So from that we can calculate the stiffness, equivalent stiffness
Exactly.
of the fixed beam. Okay, this is free vibration test. Okay. Sir, how to get the plots with this?
This is experiment, sir. The plots will be given in the explore phase.
Which page, sir? Now,
You scroll up, sir. Scroll up the explore phase,
yeah,
where you can choose your variables.
that is fine, but no, just before we have plot of this damping, decay curve.
Okay, so that is I think in experiment 2, where they'll ask you for the logarithmic decrement.
No, actually before that, in the same.
Oh, you need to then start the experiment. If you go,
Okay, start. Okay, fine, fine. Yeah.
then you can find your replacement and
Okay, this is single degree of freedom. We got one peak, and this is damping ratio. Yeah, fine, sir. Thank you.
Thank you, sir. So, anyone else? I saw Shankramurthy
Sir,
sharing
thank you so much
experiment.
for giving this opportunity.
Thank you, sir. Please, sir, you can start your experiment and you can stop your screen share.
So, okay, let us have the experiment on free vibration of simply supported beam.
Sure, sir. And your voice is echoing, sir.
Hello? Hello?
Now it's okay.
Hello? Hello?
Now it's okay, sir.
Okay. Okay, so in this experiment, so we have a single degree of freedom system. So wherein like the material is steel and it's an I section bar, where the length is 1000 millimeter and the damping ratio. I think we need to set the damping ratio. Hello. Hello.
No, sir. No, sir. If you start the
Hello.
experiment, can you hear me?
Hello.
I can hear you, sir. Please start the experiment.
Okay.
So once you press the start experiment button in control tab,
Material is bronze. C section. The length of the bar is 1443, and the damping ratio and the center of mass is 50.34. So it's been asked to find the stiffness from E, I, and L. ಮೂರು ಕೊಡಬೇಕು. So why it's not giving? See, suppose if I type 55, so then it has to give the value like in earlier case, if even if you are typing the wrong answer, in the next cycle I will be getting the right answer.
actually, sir, in this, you need to put the exact answer.
Okay. Then we need to do the calculation. Earlier
There's a
cases,
lot of disturbance from your voice.
in earlier case, in free vibration, it used to calculate. There, in the simulator, even if I type the wrong answer, it used to give the right answer in the next cycle. Check. How to go about it?
Actually, sir, it needs exact answer. If you keep, then it will say, and it will not give the correct answer as in other experiments.
How to go about it, sir? Because here I need to calculate E, I, and L. Then only I'll come to know about the stiffness. Shall I restart one second? So then, how to go about it, sir?
Okay, so let me tell you, sir. So
Hello?
Can you hear me?
Hello.
Can you hear me? Sir, can you hear me?
Hello, sir. Can you hear me, sir?
I can hear you, sir. So the thing is, this
Hello.
doesn't. I think I should type my answer.
Hello. Hello. Hello.
Sir, I can hear you, and I think
Then
there's
what's the
some.
next procedure, sir?
Okay, so the thing is, this doesn't give you the correct answer, and it only gives you the feedback if the answer is correct or not.
Okay.
And there are some of the experiment which gives you the correct answer as well. So,
Okay.
but
Okay.
this is
There we
not
need to
the case.
calculate. There we have to type value, sir.
Actually, sir, there is a lot of noise from your voice, so I think we
Okay.
can move forward for the other. If anyone is
Now can you hear me, sir?
ready
Or
to,
is it okay, sir?
can you hear me now?
Hello. Hello.
Yes, sir, I can hear
Hello.
you.
Okay. I'll stop. Somebody else can share.
Sure, sir. So, if anyone is ready to share, it's okay. They can share, or otherwise, I'll start the next lab.
We shall have a district calculator.
Go for the list of experiments. So we have 9 number of experiments here, and first is parole governor. So there are 3 governors: flight mechanics, 4-bar mechanism, balancing of masses, and flywheel. So let me start with the governor. So aim, theory, pre-test, procedure, simulation, post-test, reference, and feedback. So pre-test and post-test are here very similar to the quizzes that we have seen in the previous uh, simulations. So I'll start with the simulation. So in the simulation, so the page of the simulation is very same. So there's a problem set up in the center. There's a variable tab and there is a control tab. So and this experiment can be uh, executed in the mobile. No need for. And once I change, and there's a relationship between the uh, RPM and the mass, and according to that, the height of the uh, governor has been displayed over here. So this was that, and in the control panel we have a show graph. So if I select that, so we'll get the graph of RPM versus height, and there's a small relationship given that RPM is inversely proportional to height. So this was that explore phase. So user can change the RPM and check for the height, and can change the mass and check for the RPM as well. So this was the explore phase, and once that is done, we can go for experiment. So once we select the experiment, so we'll get two of the experiments here. There's a calculation part and there's identifying part. So the calculation, and select this. Okay. So this is experimental setup. So we have the from experimental setup, that is governor here, and these are some variables here. So that is mass is given 20 kg, Fm by Bm. If we see the free body diagram that was on the first page, we'll get to know the Fm by Bm and the RPM given. So formula here is Fm by Bm, and the mass plus the ball mass plus mass upon ball mass multiplied by 895 by h. So once we calculate this, I calculate this.
Ms. Rohit, your voice is not audible.
Recently developed, so we have kept that correct, get the feedback of the answer as well, like how much they are correct or not. And this experiment gives like is very precise about the points also, so we have to give the proper calculation and the points as well. So this was the experiment, and the thing is we can reset the experiment. So every time we reset the experiment, it will ask you different questions. So this time it's asking for the RPM. So, and for the RPM, we can calculate that as well, because the variables, that is mass of the ball, height, and these are the constant variables given. So once we keep that in the formula, and we can calculate that as well. And we can reset again. So once we reset, this, yeah. So if we reset again, so there's a find the mass. So we can graph, and we can hover over the graph, and we can find the values as well, and we can use those values for finding the mass. So this was about this experiment. So user can do multiple number of experiments in the same one page over here, and every time they reset the values, and the variables also reset. So every time they do experiment, they do different experiment. So once a user is satisfied with their experiment, they can exit the experiment. And there's a very one kind of experiment, that is identifying the part of a governor. So you can start the experiment, and we can see a photo picture of a parole governor, and with the part, we're supposed to find the uh, parts of the governor. So in the box, as we can see on the side of the arrow, uh, we can, if you press the drop down, we can find the uh, options here to select. So let's select, okay, this is fly ball. So once a user select the correct answer, as you can see, there's a correct mark over here. And if we select, let's say, sleeve, so this will give a feedback, that is, this is a wrong answer. So this was one of the experiment and a payroll governor. So if I go back to experiments again, so payroll governor is very similar. There's a Hartnell governor, and there's a dynamic analysis of 4 bar as well as slider crank. There's a balancing of a mass, and there's a disc type and rim type flywheel. So I'll select this experiment. So I'll directly move to simulation. So here in this, we can see a setup of a flywheel. So this is a flywheel on an axis, and there's a bob which is rotated over the axis with a thread. So the mass is this, and the number of revolution of the threads, the radius of the axis, the radius of this rod, and there's a radius of the flywheel can be changed from 0.4 to 0.7 kgs. So once the variables, these two are the only variables, that is radius and the mass, all other are constant, and the height of the this free falling body is 2 meters from the axis. So once we play, so this thread will uh, fall, this bob will fall, and it will give a excitation to the flywheel, and it will rotate. So once it will stop, so once it stops, we can see the calculations over here, and that is me ask to the moment of experimental motion. So so again, so this also will give you a proper feedback. So about the percentage of error that you have made, and the theoretical moment of inertia, and the percentage of error, and this. So this gave a proper feedback to a user, like how much they have, and how wrong they are, and how much is the answer and how much you need to calculate. So this was one of the experiments. So this page also doesn't need any flash play or anything, and this page only contains experiment as well as the explore phase. So yeah, once we are done, we can like that, and we can again, and we can calculate the. We can go for the experimentation. So these are two of the experiments from there, and I would like any one of you can explore one of the experiment from this lab, and they can share the screen as well. And after that, we can go further for anything. So I'll stop my screen share, and anyone who's interested can share their screen and do one of the experiment. So this anyone is there
Hello, Ravi.
wants to present? Yes, sir.
Yeah, I want to present the lab stream.
I'm sorry, sir. Like your voice is not clear. Yes, Ramesh, sir, you can speak now.
Hello, is it clear now?
Yes, sir, it's clear.
Okay, now I will share the screen.
Sure, sir.
Whether the screen is visible.
Yes, sir, it's visible.
This is Dr. Ramesh Jirgal from B.Ed Engineering College, Vijaypur. So here we need to demonstrate a dynamics machine lab, which is developed by NITK Surathkal. Here we have a list of experiments. Hello, am I audible to all?
Yes, sir, you are audible, please.
Somehow some issues are coming for opening of this particular web page. Wait, time out. This link is not opening for this particular dynamics of machine lab.
Can you, sir?
Okay. So if I click on this page, comments here.
Yes.
It is not working.
Just 1 second.
504 gateway timeout error is showing.
Yeah, yeah, it is coming in my system also like that.
Yeah, some error is appearing. Probably.
There is a gateway timeout. Yeah, some error is coming, sir.
No, I think many of us are accessing the same website. Probably.
Actually, sir, I don't have any idea about this because mine is working fine.
For,
Still, I can reload, and I don't know the reason, sir. That's what I'm checking with.
Yeah, yeah, sir. Please check it, sir.
Okay, it's showing for me also now.
Now it is getting for you.
Uh,
yeah, it is working. Now it is coming. I hope it is visible to all.
yes, sir, it's visible. Please carry on.
Yeah. Shall we go to Porter Governor?
Sure, sir.
Let us conduct the experiment on Porter Governor.
Sure.
Again, the same error. It is coming.
Again, it is a problem.
Yeah, again, there is a problem in the web page.
Yeah.
I think I'll try to continue now. And
Okay.
let's see after some time if that works. So you can continue that time, sir.
Okay, Rohit, you can continue.
All right, sir. I'll all right. So yeah. So on this mechanical lab web page here, there's one more lab from the NITK, that is Mechanics of Machine Lab. So I have already opened this. So this is the web page here. So it's very similar to the vibration lab because this is also an old lab. So we can see basic information about the mechanics of machine. As we go down, we can find the basic terms and terminologies and some of the formulas, I guess. So we can. So it's very good practice for someone who's very new to the subject and wants to experiment. So it is very good for them to go through this once. So this will give them a good idea about that. So in the experiment, so as you can see, there are a number of experiments here. So let me select. Okay, I'll select. And yeah, one more thing. This mechanics of machine lab is purely for explore phase. So there are very less experiment in this which are in the experimental phase. So user is not is only allowed to explore the experiments as we have seen earlier as well. So let's see. Okay, I'll do position analysis of Scotch yoke mechanism. So as the same layout of the page. So there's a theory, procedure, self-evaluation, simulation, assignments, quiz, videos, references, and feedback. So in the simulation, yeah. So one of the good thing here is most of the experiment here has one more option of the experiment explore phase, and for non-flash users. So like some of the users who are not installed that flash player or who wants to access the labs on their mobile phones and mobile browsers, so they can go into this option. So this doesn't need the flash. So as very similar experimental page. So as we have seen earlier also, so there is a setup of an experiment. As you can see, there's a Scotch yoke mechanism as this moves. So and in the center, and we can see the variables here. So variables are crank length. So it can be changed from 10 to 84. So as I change it, we can see the change on the screen as well. And then there's a theta, that is angle, that can be changed only if you pause the simulation, and you can keep it wherever you want. And omega, so we can change and we can see the speed as well, the change on the screen. And there's one more option over here, that is for reverse direction. So this, if we select that, so it will start rotating in the crank will start rotating in the reverse direction. So after changing the variables, so there's the option to show graphs. So the graph will be for amplitude versus time, and we can see the graph that has been traced of this mechanism like straight. So we can see this, and once a user is allowed to change the RPM, sorry, the omega. So if they change the omega, and they can see the change in the amplitude, and if we change the crank length, again you can see the change as well. So this was only one explore phase experiment. So I'll pause this. I'll go for the experiments again. So with the CAN mechanism. So the related information about the experiment and some of the calculations is here. I'll go for the simulation. So this is clan mechanism is on the screen, and which is moving. So just as says walking mechanism for mostly for robots and all. So in the variables we have OA, and you can see this red link, that is OA. So this is a variable. We can change the length of it from 20 to 46. Input angle, again, if you want to change, you can pause the simulation and we can keep it whatever we want. And once we play, and we can push the speed. There's a similar option. It's very similar in the problem setup as for the Scotch yoke mechanism. And there's a we learn in the uh, change the direction of this movement. And there's one more option, that is trace path. And let's change the OA, and we can see the path trace difference. And if we decrease the speed, we can see the path of the traced path, that curves are very sharp and steep when the speed is less, and if we increase, so as you can see, it's not very uh, as in the speed is less. So this was one of the experiment. Go for another experiment. There is okay elliptical cam. So theory has been given about the cams, and some of the formulas and some calculations which are required. I'll directly go for the simulation. So here we can see a cam, And in the variables, we have the A and B. So this is major and minor. And this angle here, if I pause it, so you can change the angle. So that we'll see why, because when you show the graph, and omega can be changed as well. And same option like in the reverse direction or in the clockwise direction. So once I say show graph, so we can see here is the position versus time graph, velocity versus time, acceleration versus time, amplitude versus time, and jerk versus time. So we can see the changes once we change the variables here. So let's change the A. Let's make A minimum, that is 12. And as we can see the change in the graph. So means like this, omega. So user is have the freedom to change the variables and can observe the changes in all of the given variables. That is, sorry, not variables like position, velocity, acceleration, and jerk. And we can reverse the motion, and we can see the jerk here, as well as the change in the acceleration and velocity and position as well. So these were some of the experiments from mechanics of machine. And before proceeding further, I would like you to go through some of the experiments and please try to uh, present one or two experiment. And as in the previous dynamics of machine lab, it may have start working. Yeah, it's working now. So yeah, please, anyone who is interested can present it. So I'll stop my screen share. Ramesh sir, I think the dynamics of machine lab is working now. You can present now. And anyone who's interested for presenting mechanics of machines can do that as well.
Okay.
Sir, we can see your screen, but there's no audio.
Hi.
Yes, yes,
Hello.
yes. Now we can hear you.
Yeah. I think now the screen is clearly visible.
Yes, sir.
So now let us see the experiment on both Ames theory. These all things are already known to everyone. So like, as we all know, this Porter governor is a centrifugal governor. Uh, Giving the simulation to means demonstrating this experiment through simulation to students gives more clarity about how this height of the governor and the radius of rotation will change with respect to mass and RPM. It's a very good development from all the IITs and NITs that they have done this virtual labs. So let us see how this height varies with respect to RPM. So here we have minimum RPM 130 and we can vary the RPM up to 180. So now if you see the height of the governor, it is 138 now. The speed of the governor and the height of the governor are they are inversely proportional. As speed increases, height will decrease. The same thing can be observed. Now at 180 RPM, we have a height of governor 138 millimeter. If it is 130, the height of the governor is 264. It is clearly visible through this simulation. So now these are two variables. Parallelly, we can vary the mass of this flying ball. If mass is governor is 264, let us check by changing this mass from 5 to 6, the height of the governor again decreased. So it is clearly visible when the mass is increasing, height of the governor decreasing. We can vary up to maximum 6 kg from 2 kg. At 2 kg mass, height of governor is 582. You can clearly visible here. When it becomes 6 kg, height of the governor is decreasing. So this visual idea gives more clarity about how exactly this portal governs. We can see these changes through the graph also. Here graph we have x and the y-axis will be RPM. We can vary RPM from 180 to 1. Sorry, we can vary RPM from 130 to 180 maximum. So accordingly, we can get the different heights. So if you click on experiment, we can do calculations. So if you click on start experiment, so for a given mass 20 kg, we can calculate what is the RPM using the standard equations what we are using for the Porter governor. We have a relation between the centrifugal force, the mass flying, and the RPM. So using those relations, we can easily cross-check the RPM. So if it is calculated properly, and we can check if it is wrong, we can get clear idea about what is the correct RPM for a given mass and a height. So we can reset these experimental values, and again we can do the cross-checkings. Yeah, that's all about this particular governor experiment. Thank you for allowing me to share my screen and demo this experiment. Thank you. Yeah, Mr. Organizer.
Yes, sir.
Rohit, yeah, you can take over now.
So that was very great explanation, sir. And so yes, anyone else who is interested to show, and someone was asking for Cam Lab. So sir, I have shared a link. So please go through it. And as I won't be able to present it as the time is not permitting,
Rohit,
time will not permit that. Yes, sir.
Rohit, sorry for the interruption. I have a one doubt. In these
Yes, sir.
particular experiments, generally when we conduct in the labs, we can change the mass as well as RPM, and all the graphs we can plot on a single sheet. So whether that
Yes.
possibility is here? This year?
Actually, sir, this is the graph is already have been given here. But what you can do is you can ask them to calculate the height for different mass, and you can ask them to plot a graph like separately, not from the uh, given experimentation, because in the experiment the graph has already been given.
Okay, fine. Okay, thank you.
Uh, yes, sir, and I'm sorry, who was presenting, sir? I didn't see that.
Hello, sir. Rohit, sir. Am I
Yes, sir.
audible?
Yes, ma'am. Sorry.
Sir, I
Yes,
was
yes,
just
yes.
asking
Please.
for SIM lab, sir, Computer Integrated Manufacturing Lab. Is there any virtual lab for that subject?
Yes, ma'am. I have, as you can see, I have already shared a
Yes, sir. But it
link
is
here, and
Yeah, it is showing CAM, computer aided, it's mechanisms and robotics it is. I was asking for computer integrated manufacturing lab. The experiment there,
There is a CAD lab actually.
yeah. So I didn't get that the same because
Okay,
when I
CAD.
just went to the, yeah.
Sorry, CAD lab. I'll share that also.
So I was asking for SIM, is the CIM.
I don't think there's lab for that. We have the
Uh,
computer-aided design and computer-aided manufacturing.
yes, yes, exactly, exactly. Where we have that programming experiments, no, and simulation of that.
Yes. Alright, so
Just
anyone
I
else who's interested can present their screen as well.
Okay, sir.
Uh, Geeta, madam.
Hello.
Madam, as we will conduct experiment in SimLab using a computer or a laptop,
Yeah.
uh, same can be recorded and sent to all the students. So it is already a virtual kind only.
Yes, this alternative we are doing it right now, sir. But
Okay.
I thought like in virtual lab, just like how we are doing for the other labs. Is there anything like that? In fact, we are doing sim lab in that way only.
Okay. Okay. Fine.
It's just programming, and you're going. We have that simulation in that particular software itself, so we are using that.
Yes,
But
madam.
I just wanted to know if there's something like that which they have done it in this particular.
Yeah. Yeah. So that our we can add some more value to our experiments. Right. Right.
Exactly, exactly, sir,
Yeah.
exactly.
Yeah. Thank
Thank you, sir.
Mr. Rohit, what about machine shop practice lab? Is there any?
Actually, sir, I think I should discuss this first. So everyone who's asking for different labs, uh, uh, there may be some of the labs for according to your interest, and there may not be. And if you want, so you please everyone who is interested to find their labs, so they can go into the mechanical lab, and there they can find. And there might be some of the labs which are not present in a particular subject as the fluid machinery and strength of material, so they are in civil labs. So it's better if you find I mean, whoever is interested to search for the experiment, they can go through all of the web page, and there are some of the experiments presented under development lab as well. So yes, that can be done. And yes, sir, you can say your question again. I didn't get you.
There's this machine shop practice lab. Okay, so gear manufacturing or cutting the lathe machines, machining.
Uh,
Yeah. So
there
those.
is a fabrication lab. If
Pardon me?
you want, I can show you that.
Yeah, yeah. Please show whatever
Okay,
is.
so okay, I'll share one of a experiment from fabrication lab, and that thing is that will take much time, and it's better if I directly play a video for that, because if I do that simulation, it will take some more time. So it's better I play a video, so you will get a good idea about fabrication lab. So let me just present it now.
Yeah, sure.
So is that visible?
Yeah, it's visible.
All right. So for everyone, I want to discuss one more point is while you go for some of the experiment, they might ask you for registering and login ID and all this information. So it's better if you, like for some of the labs which have been developed by Kharagpur or Bombay. So it's better if you register in each of the college's website virtual lab. So how it will be beneficial is whenever you have experiment developed by that college, and if they need a login and ID, so they can go through that. So as many of the faculty are asking for IC engine lab, and I have posted a link for that also. And uh, some people may find it difficult because of the login and ID. So there's a page for that. So you can go to the web page for IIT Kharagpur V Labs, and here you can register it. So if you register here, you'll get your email ID, and login ID, and password. So whenever you go to the labs developed by the Kharagpur, IIT Kharagpur, and this IC Engine lab, you can go and execute those labs. So that is also one thing. So yes, I will go for the execution lab and go for list of ceremony. So there's computer control cutting of wooden objects. So so it's very similar as we have a introduction, the introduction from theory, as you can go down and read all about it. There's pre-test theory, simulator is there, uh, procedure, audio and video. So this is lab developed by some other college. So not as this option is not in NITK labs. There's post test and other things are all everything is very similar. So I'll directly go for simulator. So this is a simulator here, and it clearly says here for running this you need flash player. So yeah, I
ಇದನ್ನು
already have
ಇದನ್ನ
it.
ಮಾಡ್ಬೋದು ನೋಡ್ರಿ.
So I'll go for it.
ಈ ಶಮಂತ್
Okay, so once it's load, so this is the user interface. So there is a watch mode. So this mode lets you watch the simulation, and there is the mode like try mode. Here you can do the simulation yourself, and there's a video. So I'll just play a video so you will get an idea. And forward this. Okay, so that was that. And if I go for try in the simulation, so yeah, this will take you to the software where they use for setting up the cutting process. So if you select on the screen, so it will ask, it will give the tips actually. So what the user is supposed to do is that open the Password software, and if we select that, this will open. And yeah, click the maximum button. It will ask you to open file. Yeah, and here is the material setup. The width and height can be set up. The thickness can be set, and units can be set like inches and this. And once in, 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 yeah, so this experiment is quite straightforward. So it opens a software, and it gives you the freedom to make the material setup. And once the material is set up, it will take you to the animation where the machine is set up, and it will cut in front of you as we have seen the video. So this was one of the experiment in the fabrication lab. So we'll stop this screen share now, and I would like to hear any queries or question, and if anyone is interested can share one of the experiments from the mechanics of machine as well. So is anyone interested to demonstrate the mechanics of machine? Or we can have a question and answer session. So for metal forming lab, actually the metal forming lab is in the mechanical V lab page. So you can go through that. Yeah, and someone has kept the link also. So anyone who's any questions, or anyone who's interested to demonstrate a lab, please do that.
You don't have anything for EC lab?
Sorry, sir, which lab?
EC lab, EC lab. Energy conversion lab.
No, sir.
Hello, sir, this is Devraj. Is there any
Yes, sir.
something for the mechatronics lab actually?
Yes, sir. There's a mechatronics lab. Just 1 second, I'll share a link. Someone is asking for machine shop, and yeah, engineering graphics lab is not there, ma'am. We are working on it. Sorry, we are working on it, and design lab is not there. Machine shop, there's the general purpose manufacturing lab that is in the mechanical web page only, mechanical lab web page only. So mechatronics labs have just shared a link. Energy lab link, energy. I think the energy lab is in the physics or some chemistry lab. Just look for it. I see mechatronics lab, heat transfer lab have sent the link as well. I see Indian lab link has been sent.
Hello. Yeah, so Rohit, are you done with the session?
Yes, we have finished some of the labs and uh, yeah, I mean almost.
Okay, so participants, thank you, Rohit. So, for any further queries, you can always write to our official ID, that is solve at nitk.edu.in, or you can directly write to support team. I'll post the mail IDs in the chat box, so you can always write to that. So today we had shown few of the demonstrations. So we request each of you to explore the other labs available and come up with the queries if any. So with this, I would like to hand over the session to Purnima ma'am.
Purnima ma'am, you have to unmute yourself. It's muted. Hello, ma'am. Purnima ma'am. Purnima ma'am, please unmute yourself. We are not able to hear you. One second. Yeah. Good evening, everybody. Thank you, Dr. Gangadharan, for your valuable session. Thank you, Dr. Prithviraj Umesh, for your experience, for your lecture on experiencing the labs through virtual tour and hands-on demonstration. I hope all the participants had a lot of takeaways. So thank you all the participants for making this session a successful one. Thank you, everybody.
Thank you. Feedback form, sir?
Thank you, ma'am.
Feedback link?
Yeah, can you send the feedback link, ma'am?
Thank you, ma'am. Thank you. Thank you, ma'am.
Yeah, so regarding the feedback, the link will be shared to the registered participants through mail. So it will be open for a specified time. So within that, we request all the participants to please fill the feedback form at the earliest. Uh, the participants who fill feedback only will be getting the certificates. So once you get the mail within the specified time, please try to fill the feedback form. So hope it is clear. So I have written one mail ID, that is solve at nitk.edu.in. So regarding other, you can write to support.
Madam, when you are going to send the feedback for link, ma'am?
It will be sent maybe in within half an hour or so, sir.
Okay, thank you.
And it will be open maybe for 1 or 2 hours at the max. Then we'll be closing the feedback forms. So try to fill within that.
Thank you, ma'am. Thank you so much.
Yeah, welcome. Ma'am. Yeah.
Thank you, ma'am.
Thank you, ma'am.